everyone. My name is John Gallagher. I'm an assistant professor in Trinity College, Dublin, in the School of Engineering. Today I'm going to talk to you about air pollution in the built environment, an area that I've been working in for more than 10 years. And I suppose I want to give you an insight into the role of an engineer, specifically looking at this cleaner and greener cities ambition that we have across the world, and how the role of myself and other engineers, how we contribute to that vision. So today I'm going to kind of give you an overview of what we do in Trinity in air pollution, give you a background and insight to air pollution for those of you who may not be familiar, but also then kind of give you an impression of how we go from understanding the problem to developing solutions. And that's a really important process that I want to kind of take you on the journey. So where do we start? Well, the air we breathe. I want to kind of give you an insight into the types of pollutants, the types of sources, because it's important to understand those elements. Then let's discuss the built environment, the city, how it's put together, the fabric, and how it interacts with the environment. Then an area that of most interest to me is air pollution control. The air pollution is in the environment, but how can I control it so that the individual, the population of the built environment, the city, are exposed to less pollution? So this little illustration is an example of the vehicle being the source, that individual being the one exposed to pollution. So how can I protect that individual from the pollution that already exists within the city? And where we go to is a green transformation. And when I talk about green, one of the elements that I'm going to talk about is green infrastructure, trees and hedges, again, an element that's illustrated in this picture, and how an engineer can contribute towards the knowledge of what to plant, where to plant, and how to plant. And you may be surprised that an engineer actually has some contribution to trees and green infrastructure when we are more known for our roles in building structures with concrete, steel, and other materials. But no, natural is also a part of what we do here in Trinity. And I'm just going to close then about the benefits of the work that we're doing and how it can benefit future cities, the legacy of the work that we're doing. So let's start with the air we breathe. In many cases, it's about what we can see. In some parts of the world, in some cities, air pollution is at such a level that it's very visible. But it's important to remember that despite concentrations maybe being lower in some parts of the world and pollution not being visible, it's not to say that it isn't there. I think this illustration is just a simple chimney plume. It could be any pollution source that we have. And that white smoke represents a mix of pollutants that is being emitted after some sort of process that generates the pollutants. And you can see the white plume as it travels to the right of the screen in that picture, that it disappears or is no longer visible. Does that mean that there is no pollution in the extreme right of the picture? No, there is pollution there, and it's important to recognize that it is not a visible pollutant that we are dealing with in many cases. Another factor just to consider in terms of the air that we breathe on a day-by-day basis is that where do we spend our time? The outdoors or the indoors? Typically, we spend 90% of our time indoors, and it's a very important part of protecting what we're exposed to on a day-to-day basis. Today, though, most of my time is going to focus on the outdoors, but it's important to acknowledge that why we're focusing on the outdoors is because despite it only representing perhaps 10% of our daily time and location in which we're exposed to pollution, it's the pollutants that we're exposed to in that time and the high concentrations of these pollutants that make it highly toxic to urban populations. These criteria pollutants, these pollutants that we have set internationally agreed limits on, have been assessed, and we understand that there is negative health impacts. Therefore, my interest in the built environment is to ensure that we mitigate, we control air pollution when it's in the air, so that an individual in their daily activities in the city are exposed to less pollution. So what I'm actually talking about in mobility in the outdoor environment is personal exposure, or population exposure, which is the cumulative exposure of each individual. But I think it's important that we look at it from a personal exposure perspective. From you and me, what do you do on a daily basis that leads to you being exposed to high level of pollution or extremely high concentrations at specific times? So this is actually a historical track record of some of the activities that I undertook when carrying some air pollution monitoring equipment through the city over 24 hours. You can see some of the activities that led to me being exposed to very high concentrations. I should point out that this is in relation to a pollutant called particulate matter, PM, small fine particles. And you can see the activities that I was exposed to very high concentrations. Out of the office at lunch, I walked to a sandwich bar to get some food. I was commuting. I was cooking indoors at home, but perhaps not ventilating well enough. Driving to the train station, being outdoor environment again. And lastly, commuting by bus. All of these activities represent the largest peaks in my day-to-day activities and represent the areas that I'm interested in trying to reduce and mitigate and control. So, the built environment. Now we have an overview of the pollution, but now we need to understand what pollutants we're dealing with in the built environment. What are the urban sources? I suppose a lot of the focus that we undertake here in Trinity in our air pollution research group is in relation to vehicle emissions, transport, because typically that is the most common source that we are exposed to on a very nearby basis. So when you're walking through on a sidewalk through any street in a city, typically you're not that many meters away from some vehicle movements and emissions. And then obviously we want to link it with the health impacts and indeed the impacts on the environment. So when it comes to the work that we do on controlling pollution, we need to think about the source. In this case, our main focus, our primary focus is transport, and think about the individuals moving around the city and how they interact. Because what we're trying to do is consider the acute and the chronic exposure of individuals to these pollutants. When I say acute, what I'm thinking about is those short-term high concentrations, those peaks that I showed you in the last slide. Because those high peaks, when reaching extremely high levels, can lead to short-term and sudden health effects, things like heart attacks. However, or maybe respiratory problems like asthma attacks as well. But on the chronic side of things, long-term, exposure to high concentrations over long periods, extended periods, over years, can lead to more long developing illnesses like cancer. So when it comes to what we want to do and how we want to make our cities cleaner and greener, we want to control the pollution in different ways, and we'll discuss that in a few minutes. So the built environment is complex from the source to the receptor, the individual, and the pathway in which that pollutant transports itself and how you breathe it in as an individual on a day-to-day basis. That's really what we want to disrupt. We want to engineer solutions to disrupt that pathway. Then it's also important to acknowledge that no one solution fits every location. And that's something that creates a challenge for us as engineers, because ideally you want to develop a solution, a single solution. But our solutions have to be flexible, they have to be tailored to every urban setting. So the built environment is very complex, and this is just a few illustrations that demonstrates, one, the geometrical variations that exist within the city. On the left you have 4 illustrations of 4 different streets, some broad, some tall, some narrow, some wide. And what you have to recognize is that pollution in its transport from a source, from an exhaust of a vehicle to your breathing zone where you're breathing it in, the air that flows through these different streets behaves differently and transports the pollution from the source to the receptor, to the individual. We want to disrupt that. So you really have to have a broad understanding of a very complex interactions between the environment and the built components. Then you have these green elements that I suppose an area in which we are very interested in. Those green boxes in the illustration below and on the right. They represent trees and hedgerows and green infrastructure. And these are elements that are typically not represented on many maps. So if you had a geometrical 3D map of a city, in many cases green infrastructure, other elements like that, which also influence airflow, can be missing. And they are a really important part of our city. And what we propose is, can we manipulate airflow? Can we engineer airflow along with the geometry of the city to disperse the pollutants, to capture the pollutants, to create a more sustainable and healthy, cleaner, greener environment? Cities of the future. And like I said, air pollution is influenced by the geometry and the airflow interactions. But there's other environmental factors and also complexities of the traffic themselves. The movement of traffic influences the sources of the pollution. Then other environmental conditions. Is it raining? Is it cold? Is it hot? Is the air moving upwards and downwards, or just in a lateral way? And then other physical features can influence how the air interacts in an urban setting also. So it's a complex environment that we're dealing with, and therefore the solutions require an in-depth understanding of all of these factors that are summed up in a few moments. So where does an engineer come in this process? This is an illustration that I created many years ago to position myself as to why I do what I do. Measurement and modeling is very important in terms of understanding the air, being able to understand the air in many different locations when you only have so many locations where you have monitoring equipment, for example. But as an engineer, and this is what we're really focused on in Trinity in our air pollution group, is mitigation, is solution oriented. We want to develop and implement solutions based on the understanding of measurement and modeling studies. The science is focused on measurement and modeling. The engineer wants to take it further and use that information to develop solutions, and that's what we do. So, how do you envisage the city that you live in, wherever you are around the world? Do you see us achieving a zero air pollution city? Do you foresee a zero air pollution city as the one that you live in right now? I challenge that. I find that difficult and to believe in the short term. I think there is a long-term future that we will attain this, but right here, right now, we are still being exposed to high concentrations of air pollution, and air pollution is affecting people's health globally in the built environment. So solutions are needed now. I enjoyed this picture on the left that was also featured on the opening slide. It was an individual, perhaps a child or an adult, that wrote this on a footwalk in Canada. And I thought, that's amazing that a kid is thinking about stopping pollution. I hope that kid becomes an engineer and comes to Trinity and is part of what we do here to try and deliver and stop pollution. But is it achievable? Let's look at the 3 approaches that I suggest that will help us get us there. So firstly, we want to lower the quantity of pollution. We want less pollution being emitted in total. Secondly, we want to reduce the emissions intensity. What does that mean? That's essentially trying to reduce the quantity of emissions from a vehicle that is polluting by making it more efficient. And thirdly, in the scenario where there is pollution, where the first 2 steps have taken it to a certain level and we still have pollution, how do we control the concentration in the air so that the individual is not exposed to high levels of concentrations in their daily outdoor activities in the built environment? So in quickly looking through these 3 areas, firstly, lowering the quantity of pollution. We've made much progress in steps towards lowering the quantity of pollution. Over the years, we've implemented fuel bans in some parts of cities around the world. What that has meant is that we have essentially reduced and improved the quality of what we're burning and stopping pollution. We've implemented measures like congestion charges to try and stop people or incentivize people to use alternative and greener forms of transport, like the green electric vehicle in the picture below the congestion charge sign, a zero emissions vehicle in the built environment. And then also, with that, we have increased our visibility of public transport. We have become more connected. We have integrated our public transport services to ensure a more flexible and attractive approach and alternative to driving. So we're getting there. But that only takes us so far. It reduces the overall quantity of emissions. Then we want to reduce the intensity of emissions. So we have a vehicle, but how do we reduce the cumulative quantity of emissions from those vehicles or vehicle? Well, in some countries we've implemented taxes which incentivize lower emission vehicles, more efficient vehicles, and that has really improved the quality of the vehicle fleet in many cities, in many countries around the world. Technology has also influenced and improved a reduction in emissions by the introduction of something like a catalytic converter. We're capturing some of the pollutants and preventing them from being emitted. And also areas like biofuels where we're changing the fuel so that the emissions are improved. But that's 2 of the 3 areas. And the third area, which I'm going to focus for the next few slides and for the rest of this talk, is the area that we're most interested in Trinity, us engineers. Controlling pollutant concentrations. Because it's an area that we forget about. We're trying to solve, many people are trying to solve the pollution so it's not created. But unfortunately, we're in a situation where pollution is still being created, and therefore we need solutions, long-term solutions that have a legacy, that have a long-term benefit. And this is where our expertise lies in our air pollution research group here in Trinity. We've been working with international experts also to share our knowledge and for them to share with us, so that as a community we progress more effectively and we implement more successfully. The idea that implementing physical barriers, roadside barriers, between the source, the car, and the receptor, the individual representing the population, in their movements around a city, so that we have the ability to control and mitigate the concentration that an individual is breathing in. We're not taking it down to zero, but we're helping move towards that. Because the question is zero feasible? So, these barriers, we classify them as solid or porous, and I think this illustration gives an example of this green structure. Could be a wall, or it could be a hedgerow, or a tree, or a shrub, or some sort of physical impediment between to disrupt the pollution pathway. What is different about a solid versus porous barrier? Well, really, in this source receptor pathway, the source again being the tailpipe of the vehicle, the receptor being the individual, it's about whether or not you are influencing dispersion activities. So imagine the air is flowing around a city. Are you only trying to mix it a bit more? So reduce the concentration by dilution, so to speak? Or do you want to actually remove the pollution also? And therefore having something like a hedge or a tree where the air can flow through it, but with the right type of leaf and structure of the green infrastructure, you can capture the pollutants. They can be collected on the leaves and the branches of the trees. So for us, what we want to do is to work with various stakeholders to try and various experts in other fields, not just engineers, is to try and design these to maximize dispersion and or deposition depending on the needs of the individual city. So you have to consider the pollutants that you're dealing with and what you want to achieve. So have a moment. Look at the 4 different pictures here. These are just examples of different green infrastructure being introduced into a city. The top left, A, is where we have no green infrastructure. Maybe the current situation in a street near you right now. And the other 3 represent the idea of adding different forms of green infrastructure to a city street. This is what we call passive air pollution control, where we're not implementing technology that needs energy. It's passive by nature. The tree, the hedgerow, the roof, the wall, all green infrastructure, but passively removing the pollution or influencing the concentration. So maybe you prefer having a low hedge or nice tall trees or a nice green wall on your building and green roofs. They're all valid solutions. But again, we all want to provide you with guidance and best practice on where you locate them, how you locate them, and these factors, which are the engineering challenge. Their location, where exactly you should put them, what size they should be, and shape. What type of pollutants do you want to actually remove? And what sort of species of tree best suits the environment that you're in. In Ireland, we have a very temperate climate. We don't have extremes in temperature, and therefore, compared to a Mediterranean city where hotter temperatures can occur, therefore, the type of tree, the type of species, is something that we need to consider. I must admit that for me, when I think of trees, I see them as a physical structure. It's very cold of me, perhaps, in some ways, but I see it as a physical structure in which reactions take place and it influences dispersion. It permits deposition, it allows particles to settle on the leaves, but you need a certain type of leaf and you need a certain type of tree for that. So, I'm an engineer. I don't have that sort of knowledge. And again, it's so important that we work with other experts from different backgrounds because this is a multidisciplinary problem. However, the engineer's role is very important because we understand how to place, how to investigate, how to measure, how to model, and how to mitigate. But we are part of a larger group that is required to achieve the desired outcome. So what's in our toolbox? This is how I frame it to achieve passive air pollution mitigation. Well, in our toolbox is a broad understanding of all of the different factors that influence passive air pollution control. And it's this cumulative understanding of all of these factors that govern the outcome we want to achieve. Things like the urban morphology, the shape and structure of the streets in the city, how airflow patterns occur within that specific environment, and indeed any type of urban built environment. The pollutant type and their characteristics, because every pollutant behaves differently. Some are quite reactive, some are quite inert. They just travel along and don't really interact with other pollutants. Where are the sources? Where are they? What are they? What other environmental conditions affect us? Do the pollutants interact themselves and react? And then also, what is really important and to end on, the source receptor. Next time you're walking down a street and you see a car stopped at a traffic light, perhaps beside you, and you look at that tailpipe and you see pollution, that's the source. Now you ask yourself, what is the receptor? It's you. And everything you can do to disrupt that, to engineer solutions, to improve the dispersion or deposition of pollutants being emitted between that tailpipe and you, can improve the air quality and reduce personal exposure for you. So, we're looking for a green transformation for cities. Because green infrastructure can lead to cleaner air. This is just an illustration from colleagues in the UK who have published this work on proving and generating evidence that green infrastructure, low-lying and high-rise green infrastructure or hedges and trees combined can change the concentration that an individual would be exposed to by implementing such a solution in the built environment in a street. I think a nice illustration on the right of a city pre and post green infrastructure implementation and growth. The particles, the average concentrations, if you can see this in the center of the slide, represent different types of particles, so different sizes of particles and different sources of particles. And what's most impressive is that the numbers represent a reduction of between 15% and over 50% of particles that you're exposed to simply by implementing these trees and hedges and then walking on the other side. I always say to people, when you're walking through a city, if you're right beside a park and you're walking on the outside of the park, why are you not walking inside? Because the concentration may be half or more. So the reductions are evident across a range of different harmful particle pollutants in this case, because they deposit in the hedges and on the trees, and also they're dispersed, they're mixed more. So the air is cleaner on the other side. And if you look at the illustration before I go on this slide, there's knock-on effects and benefits. They're evident. Look at the number of people sitting outside in this area, the number of people cycling. It creates a more amenable, attractive environment for people. And so this green transformation isn't more than just cleaner air. So the work that we do in Trinity, in our air pollution group, we work with other international experts who are experts in modelling and measurement, and indeed mitigation in the same field as ourselves. We've worked in international projects to try and develop guidelines that help us implement these passive air pollution controls. Most recently, the project was called iScape, led by our partner university in Dublin. But we've been working in this field for more than 10 years and had a lot of contribution to the solutions developed. Some of the legacy work that I did as an early career researcher has helped support this idea. And what I want to highlight is that the research informs the key decisions. Our research is what is then translated and utilised by urban planners and policymakers. And what we've done as engineers is help develop best practice guidelines. Obviously, that is needed to working with other stakeholders and other experts that are non-engineers, so that we could create something that has a universal language and practical implications for cities across the world. But I must highlight that the idea of planting trees in cities sounds fantastic, but it comes at a cost. So we also focus on ensuring that when we implement solutions, even though they come at a cost, we want them to make economic and environmental sense simultaneously. We want to maximize the positive impact. So some of the work that we've done and collaborated with other international experts is to look at identifying pollution hotspots, these areas in red that are considered the most polluted in a given street. And we focus our green infrastructure solutions in those areas. So what we're trying to do is maximize the benefits. If we cannot afford to implement green infrastructure everywhere, we want to put it in the right place. And that is the role of an engineer, to find solutions where the problem is the greatest. And so, long-term outdoor air quality and improving that is where we foresee green infrastructure being an important part of the built environment. But I just want to expand on that. From air to environmental quality. It is so important to recognise the multiple benefits of green infrastructure in cities beyond air quality. Controlling heat and temperature, allowing drainage for high rain events, biodiversity benefits, etc. The list goes on. Physical and mental well-being can be affected in a positive way through the implementation of green infrastructure. And if it is driven by better air, then future cities will benefit in that ambition of achieving zero air pollution in our cities. The legacy of green infrastructure will live on. So that is for me today. Thank you for joining. It's been a pleasure. I want to leave you with this picture of stop pollution. Some kid somewhere in Canada, in Montreal, put this on the street that I took a photograph of, and it stuck with me, and I hope it sticks with you. The ambition of our work in the Air Pollution Research Group in Trinity is to help achieve and stop pollution. If you want to find out more about our air pollution research, visit our website. And if you want to find out more specifically about our passive air pollution control work, visit the link. Thanks for joining.